Hey guys, if you've been having some trouble with special right triangles, this video is for you. We're going to talk about formulas involved with finding the side measurements of two very special triangles. They're two right triangles and they're two specific right triangles. Your 45-45-90 and your 30-60-90. So let's look first at the 45-45-90. These formulas are concerned with finding the side lengths of, for right now, this one particular triangle. So let's just say, if you have a 45-45-90 triangle, first of all, your base angles are congruent. So that means that your two sides are congruent. So if I tell you that this side over here is, say, 3, well, you automatically know that this side is 3. Now, what would you do to find the hypotenuse? Well, that's going to use your Pythagorean theorem, right? So let's just go ahead and take these two numbers and do it real quick. If I do 3 squared plus 3 squared equals, say, h squared, we've got 9 plus 9 equals h squared. So we've got 18 equals h squared. Then we're going to take the square root of each side. So I have h is equal to the square root of 18. Now, side note here, we do need to simplify this. What's a factor of 18 that is a perfect square? 9. So we could break this down into the square root of 9 times 2. The square root of 9 comes out. So that's going to be 3 square root of 2 for your final answer. So that hypotenuse is 3 square root of 2. Now, let's look at what happens if we do this with a variable. And the reason we have these is because the 45-45-90 triangle is very, very common in everyday life. And needing to find that hypotenuse quickly is a good benefit. This, while it's not hard, it's not very quick. It takes a little while. So if you can have a short formula to find this side so that you don't have to use the Pythagorean theorem every single time, that's the benefit. So it's not that you don't know how to find these measurements, it's that you don't know how to find them quickly. Okay? So let's look at what happens with a variable. So let's just consider what would happen if we were told that one of the legs of a 45-45-90 degree triangle was equal to x. Well, we know that since, and remember, the hypotenuse is always the side that's opposite the right angle. Only that side can be the hypotenuse. A leg can't be a hypotenuse, and a hypotenuse can't be a leg. So find your hypotenuse, and the other two sides are always legs. If this leg is x, then the other leg is x. So let's go ahead and use the Pythagorean theorem on this triangle now, if we let the hypotenuse be h. So now we have x squared plus x squared is equal to h squared. Square of the side plus square of the side is equal to square of the hypotenuse, Pythagorean theorem. And simplifying gives us 2x squared is equal to h squared. Now if we take the square root of each side, solving a quadratic equation using your square root method, we're going to get, well, what's the square root of x squared? It's just x. So we can pull it out from under the radical sign. However, the 2 is going to have to stay under there, and the square root of h squared is h. Now this becomes the third part of our triangle as far as formula goes. We can say, well, the hypotenuse then is equal to x square root of 2. You just derived the first formula for a special triangle. Anytime you have a 45-45-90 degree triangle, your sides are in a ratio of x to x to x square root of 2. Now let's look at how we can apply these formulas when we know something. For these kind of problems, you only got two scenarios. Either you will be given the length of one of the two legs, or you'll be given the length of the hypotenuse. So let's look first at what would happen if we were given the length of one of these legs. Let's say we're told that the x, or one of the legs, is equal to 5. Well, instead of going through all the Pythagorean theorem, all we have to do is say, okay, if x is equal to 5, that means this leg is 5, This leg is 5. This leg, we just substitute in the x for this x. So now this leg is 5 square root of 2. See, that's all you have to do. That's why these formulas are so helpful. Once you know x, you just substitute it in here. Don't lose your square root of 2. This is the length of this hypotenuse. If we use the Pythagorean theorem, this is what we're going to get after we simplify. So let's look at the next scenario when we might be given a length of the hypotenuse. Let's say in this problem they told us that the hypotenuse was equal to 5. Now that's it's a little more complicated because we don't just have an x, but take the formula for the hypotenuse and make an equation. So we're going to do x is x times the square root of 2, which is the representation of this side, equals whatever number we're told. Now we're going to solve this for x. How do you solve for x? Getting rid of things that are attached to the x. In this case, the square root of 2. It's been multiplied by x, so to get rid of it, I'm going to divide by square root of 2. Whatever you do to one side, you have to do to the other. Now over here, these two cancel out, and I have x is equal to 5 over the square root of 2. Now at this point, you might have to rationalize this denominator. Some teachers are requiring that, some aren't. So read your directions, know what your teacher wants. If you have to rationalize the denominator, you're just going to multiply top and bottom by square root of 2 over square root of 2. And that's going to give you 5 square root of 2 over, now square root of 2 times square root of 2 is square root of 4, which is 2. So this is the length of a side. So we were told the hypotenuse was equal to 5. So that goes here. Now x equals 5 square root of 2 over 2. 5 square root of 2 over 2 on both sides. So you see how much easier that was than having to use the whole Pythagorean theorem again? Okay. Alright, let's look at the 30, 60, 90 degree triangle now. Okay, here's your 30, 60, 90. Now, I'm not going to derive these formulas like I did the last one. It's a little more complicated, but it's the same type of thing. You just use the Pythagorean theorem based on an equilateral triangle, and you split it anyway. If you're interested in that derivation, let me know in the comments, and I will make a video on how these formulas were derived also. This is technically something you just have to memorize. You usually learn this in geometry, but you don't really have to use it until trig. And then by the time you use it for a few days over and over and over, you have them memorized. But you're going to need to know that the hypotenuse of a 30, 60, 90 is 2y. The longer leg is y times the square root of 3, and the shorter leg is your base value, which is y. So let's look at scenario number 1 of a 30, 60, 90 degree triangle. This is your little formula that you've got memorized or written down on a piece of paper or whatever. The problem tells you that side number 1 is equal to 6, and you need to find the other two sides, the lengths of the other two sides. So, come over here to side 1, which is the side opposite the 60 degree angle. Let's take the variable expression, y times the square root of 3 equals the value that they gave us for this side, 6. Now we're just going to solve it for y. What's attached to the y? The square root of 3. It's been attached by multiplication, so I'm going to divide both sides by square root of 3. These cancel out, so now I have y is equal to 6 over square root of 3. Once again up for debate, do you need to rationalize that denominator or not? That will be indicated to you in either your directions or by your teacher, so check that. If you have to rationalize it, multiply both sides by the denominator, top and bottom by the denominator. When we simplify this, we're going to get y is equal to 6 square root of 3 over, now square root of 3 times square root of 3 is the square root of 9. And the square root of 9 is 3. 6 over 3 will reduce down to 2. So we have y equals 2 square root of 3. Now this is your base value down here. Now I know that number 1 side was equal to 6 already. I was given that. Now I know that number 3 side here, since it's just y, is equal to 2 square root of 3. Now to find number 2 side, I'm going to multiply times y. Well, here's y, so I'm going to have 2 times 2 square root of 3, which will be 4 square root of 3. So this side is 4 times the square root of 3. And that's all there is to it. Let's look at the next scenario. In this problem, we're given that side number 2, which is our hypotenuse, is equal to 3. So, take the value you are given and make an equation using the variable expression for that side. So we're going to put 2y equals 3. And then we're just going to use the basic steps for solving an equation. Divide both sides by 2. So y is equal to 3 over 2. And that pretty much completes the rest of our puzzle. If y is 3 over 2, then this side is 3 over 2 units. Given that, so we knew that was 3. Now when I plug it in over here, that's going to be 3 halves n for y times square root of 3. So 3 square root of 3 over 2 is this side. Okay, and that's the value of all 3 of your sides. Now let's look at that one last scenario when you might be given side number 3. Okay, let's look at this last scenario where you might be given side number 3. That's the shorter side down here. And this is the good one. This is the one that's easy. So if side number 3 is equal to 5, we can put that down here. Y is equal to 5. And you don't even have to solve an equation. That is the answer. So now all we have to do is substitute this number up here in these other 2 sides for y. If I substitute 5 up here, then that gives me 10. If I substitute 5 here, then that gives me 5 square root of 3. And that is the length of the 3 sides of a 30, 60, 90 triangle. Now I'm going to work through one more example on each triangle. So if you're still a little bit fuzzy, this might help solidify it a little bit. Hang on, let me get set up. Okay, let's work one problem with each triangle. First, let's look at a 45, 45, 90. And I've got the formula written here that I had to memorize. That's just something you have to memorize. Like I said, it's not that hard once you do a lot of problems with it. And it's not that hard to figure them out if you need them, but it's not hard to memorize it if you're taking trig anyway. So we are given in this problem that AC is equal to 2 square root of 3. Now where's AC? It's right here. Okay? So this side is equal to 2 square root of 3. The variable for this side, the variable expression is x. So I can say x is equal to 2 square root of 3. I don't even have to do any solving. If I needed to, I could, but I don't have to do any solving. So I can go back and say, okay, BC or CB is also going to be 2 square root of 3 because they're the same. Now, for my hypotenuse, I'm going to substitute this in for x. So I'm going to say 2 square root of 3 for this x times the square root of 2. And when you multiply radicals, if they have the same index, and both of these are square roots, you can just multiply the 2 numbers. So I have 2 square root of 6 for the value of this side. Now let's look at an example, one last example on the 30, 60, 90. I have it labeled. Once again, I have my expressions here because I memorized them. I'm trying to find the measures of all 3 sides. I'm trying to solve that triangle. And I'm given the measure of AC. They tell me that 2 square root of 3 is equal to this one. So I'm going to make an equation of my answer 2 square root of 3 equals the variable expression. Now I'm going to solve it, and that means I'm going to get x all by itself. What's attached to the x? Square root of 3. So I'm going to divide both sides by square root of 3, and yes, I know you could probably just look at this and tell what x is, so you do you. These two cancel out, so I have x equals 2. Now that's just x. That's not necessarily a length of the side, but that's my x. I take this information back up here and I'm going to fill it in where I need to. So I already know what AC is. Now AB is equal to 2 times x. Your x is 2, so this is going to be 2 times 2, which is 4. That's AB. And then BC is x. What's x? 2. So, you see, special triangles are not really that hard, but you do have to do the brain work and you have to memorize these formulas. And just realize you're going to be given one side and your job is to find the lengths of the other two sides by solving the equation and then going back and substituting into the variable expression. Okay? Well, please let me know if you need some more help with this, because I can work more problems if you need them. I'll see y'all next time. Bye.